8-1 homework on page 351 is where we're starting today. So, bunch of problems here to try to solve equations. What did we do on this first group to make them be set up right to start? How do you have to start these? Make it equal 0. So we need to get all of these problems to equal 0. You might have to distribute, you might have to combine like terms, you might have to do some opposites, but we want to get everything stacked up on a side so that the problem equals 0. After you get it to equal 0, we want to use an old skill from chapter 5 called factoring. And you should be able to get two factors out of these. And then once you get your two factors, we just need to read answers off of our factors, basically. Let's take on some answers. You weren't even here. Why don't you just join us on 351. Try to do number 1. I think you're going to be able to do it. What do you think for 2? Join us there. Just do it. I think you can do number 2. 3, we skipped. What do you think about 4?
7 and -1.
It is that. 5.
-2 and -5.
It is 6. 7, we get our first fractions because it's the first factoring where we had to do a little bit of guessing to get it to work.
2/3 and -1.
Those are both true. 8's one fraction and one whole number. Do you need a second to get a factor to do it? Yep. 9, 10.
-2/3 and 4.
That's close. Let me check back with you on your factoring. It's like a little bit off, I think, maybe. 11.
-5/3 and 1.
It is. 30.
-1/4 and 3.
And that's true. You skipped poor Justin then. Do you have 14?
This is page
351,
14, -7/2 and 8.
That's true. 15. 16's unusual because when you factor, it's a perfect square and it only has one answer.
Let me try it.
Okay, let me get back with you on 16 then. 17? Okay, try 17. I'll get back with you and then we'll call a timeout. Unless we can get you with 17. Did you get 17? Would you say -2? And I agree with that, so he just let you off the hook. Again, that first lap, if you're not sure what to do, you get the problem equals 0, then you factor it, and the factor leads you to some answers. Anybody ready with a cleaned up answer on that first zone?
Well, my sign's just wrong, it's just 2/3 and 4.
It is. 2/3 is right, and then the 4 should be a -4. Anybody else ready to clean up? 1?
Just 5 and 1.
It is 5 and 1. Yep, see, told you you could do it.
6 and 1.
It is 6 and 1 for number 2. Yep, yep. Anybody need some help on the first zone while we're waiting for a stray? One or so more answers, I think we're lacking.
Walk in, Matt. Walk in, Matt. Walk in, Matt. There you go.
Factor up, man. Factor mania. There you go.
Let's skip down to 19's group. 19's group, we had a change of pace. What was different about the problems in 19?
There's no x.
There's no x
Regular
term. So what we did on these is we got the x squared alone, and then we did a root. Anytime you do a root, what's going to happen that creates there still being two answers when we do the root? A plus minus. So 19, volunteer, 19. Yep.
Plus minus root 5.
Plus minus root 5. We're going to get a bunch of answers like that for a little while. 23. If you had, well, somebody give me an answer for, let me skip 23. Let me go to 25. Anybody have an answer? 25.
Root symbol over 5 over 3.
Say again?
Like a root symbol over just 5 over 3.
Okay, we could try that, but I was hoping someone would actually say that, because I'm gonna criticize that slightly. So, if we go to do number 25, you would end up with a 5 getting on top of a 3, and then you would end up having to do a root. And this would be positive, because I think it's a negative, maybe dividing a negative to get a positive. Okay, but does anybody need help 25 to get to this part, like to a position like this on 25? Then why would I, or not, it wasn't 25, it was 20, no, it was 25.
It was 25.
If we get to a position like this on 25, any thought on why I'm criticizing that? We're not allowed root on the bottom. And this does, in disguised way, have a root on the bottom. This is root 5 on top of root 3. Whether you write it like this or whether you write it like this, they mean the same thing, but this does have a root on the bottom. So memory from last chapter. How do we fix that?
Multiply it by the roots.
Multiply the bottom by
Root
3, so the bottom becomes
3.
3. The top has to
Root 3.
multiply root 3 to make
Root 15.
root 15. So if you say that is your answer, I'm happier, but still critical. I'm so critical. Yeah. Why am I still critical of
Plus,
this?
minus.
Plus minus. Every answer in this whole section, save maybe 1 or 2, is going to have a plus minus. Plus minus is going to go on virtually everything in this zone. Why did I say virtually everything and not everything? What's the one, you have one exception answer. Yeah, why is that an exception?
Just the answer 0.
The answer is 0. 22's answer is 0, and you're never going to put plus or minus 0, because 0 is not.
plus or minus.
It's not positive or negative. It's just in its own club. So 22 is just 0. But every other answer in this whole section is going to be plus or minus this, plus or minus that, plus or minus this, plus or minus that. About half the answers have something else in them that people might mistake. Every answer from 27 to 34 has this, an I. Why do they have I's? When do you get I's?
When there's a negative under the root.
If you're rooting a negative. So if I go back to this question and one of these had been a negative, we'd have done the same answer, but we'd have stuck an I out in front of that thing. So to summarize again, this group, especially if you weren't here, here's your seminar, get the x squared alone, and then do a root. If you're rooting a negative, make sure you include an I. That's going to happen from 27 to 34. Make sure you do the root if you can, simplify the root if you can, make sure there's not roots on the bottom all the time, and every answer is going to have a plus or minus on it. Does anybody need more guidance than what I offered there to get through to 36?
Can you work from 19 to 35?
Yeah, like I'll make a new one up. So if I had 7x squared equal 28, you'd go x squared equals 4, and then you do the root. When you do the root of 4, it's not just 2, it's also negative 2, which a simpler way to write that is plus or minus 2. If this were a 35, and this were a 5, you'd go root 5, plus or minus. If this were a negative, this would be a negative, you do the exact same thing, but imaginary. And if you got to something like you were rooting 20, we're still wanting to make that something like 2 root 5. Do you remember how to do that?
Yeah, what did you say?
Because like 4 is the square that goes in 5 times, 4 becomes 2. You good to follow that, jumping through hoops? Okay. Anybody else at 36 need help? Okay, 37 to the end, these all equal 0. Was that good or bad?
Good.
Good. Did we want to factor? Yeah, factor how?
Take out GCF.
Take out a GCF, which was always going to be an x, or maybe even more. So if we're taking out an x, what's an answer for every answer the whole way rest of this? 0. It'll be 0 and a friend. So 37 is like 0 and 5. Last one, 44, would be 0 and negative 8/19. If you're getting the first one and the last one, you probably got the ones through the middle. Anybody 351 need any more guidance of how to do yesterday's life than what you just got? If you did that all the way, send it down. A couple people already sent it down, and I think I already checked those in yesterday. So if you have already a big check on your paper, you don't have to send it to me again. You already got that to me yesterday when you finished in class. Last call, 351. All right, so then we step into a new world today. Yesterday, all the equations had at least an x squared in them, usually an x, usually a number. Anybody remember what those were called? What type of equations? Quadratic. So what we're going to do today is learn a thing called the quadratic formula, which is the solution to how we can solve quadratic equations. We talked a little bit yesterday about why this is even necessary. Why is it necessary to have another tool in our toolbox?
Because
Some equations can't be factored. In fact, I might go so far as to say most equations can't be factored. Unless somebody like a teacher or a book author is being kind to you to rig them so they'll factor. If you just randomly picked numbers, pick any number you want. 3, pick any number you want.
17.
Pick any number you want.
29.
Pick any signs you want.
plus minus.
Okay, that won't factor, not even close. There's no way, okay? I won't waste your time and do that all day, but if we did random number choices and random sign choices and we just created problems like this, it would be almost never would you stumble into one that happened to factor. Okay, so we need another tool in our toolbox. If the problem can factor, you do want to factor it. Factoring is easier than what we're about to do. But what we're about to do is more useful because it can do any problem. If you could do it by factoring, this also will work. You could go to yesterday's homework and run this scheme every time, and it would work every time. But if you take yesterday's scheme and try to run it in today's homework, you'll probably get like 4 right. Okay, very few of today's are going to factor. Some of them will, most of them won't. If you look around the board, let me know if you see one that happens to factor. I'm not saying they do, I'm not saying they don't. I'm saying they probably don't, but might be tacking equals 0 onto that. So here's what we're after. What we're going to do is just consider the number with the x squared, we're going to call it a. The number with the x, we're going to call it b. The other number, we're going to call it c. If you don't see a number there, invisibly, who's there? A 1. What if you don't see that part of the problem at all? Like you don't even see an x, then what would the number be? A 0. Okay, so I didn't do any on the board that would have zeros, but if I completely skipped one of the 3 portions of x squareds, x's, and numbers, that portion would be a 0. Then we just have to memorize this. And people always say, oh, well, it's just how it is. So if you memorize this, you're going to get all the problems right. If you don't memorize this, your test is going to be an F. Okay, we have to memorize this formula. It's always going to be the opposite sign of the b, plus or minus, because there's 2 answers. So we could add or we could subtract a square root that has b squared minus 4ac. That's all the top of a fraction, and the bottom is 2a. And we're just going to need to stick the numbers in the right slots, and you'll get it right every time. Jot that down and work on getting that in your brain, because on the test you just need to know that. Is this one ready to rock and roll right now?
Yep.
No, why not? Not equal to 0. So I want to go 3x squared plus 5x plus 1 equals 0. The 3 I'm going to call A. The 5 is B, the 1 is C. So that formula tells me I need to take the opposite sign of what B is. So negative 5. What if this were a minus?
So it'd be a plus.
Then this would be a positive 5. I'm going to add or subtract a root. B squared, 25, minus 4 times A times C.
13.
12. All on the top, 2 times A on the bottom, 6. That's our start. Question about start? Then you clean up. Sometimes you can clean up more than others. What can you clean up here? 25 minus 12 is 13. Can you do anything about the root of 13?
No.
So you call it a day, and that's your answer. Your answer would be -5 plus or minus root 13 on top of 6. That is 2 answers. We don't want to do root 13, because if you try on your calculator, what's going to happen? It's going to go forever. Okay, but if we wanted to, we could go -5, adding the root of 13, see what it is, divide by 6, see what it is. It would go on forever. That would be an answer. Then you could do -5 and subtract root 13. Divide that answer by 6. See what that is. But that's, you don't want to use your calculator. Just put that. It's simple. Question on that? They're all the same. There's not much variety in this. So this I'm calling
A.
A. This I'm calling
B.
B. This I'm calling
C.
C. But take notice that C's not 2. C is -2. So make sure we bring the sign. C is -2. So I'm going to go opposite of B,
-4.
plus or minus root B squared, 16, minus 4 times A times C.
-23. Oh, -40.
40. So if we're already committed to subtract, and then are you telling me 40 or -40? -40. So if we're committed to subtract from the formula, and then you're telling me a -40 from this, that's a plus 40. All on the top. Okay. Question about how we got the numbers in the slots.
How do we get 40?
We're going 4 times A times C.
Okay.
So 4 times this is 20, times that is up to 40. And since we got a negative, we had also a minus minus made plus.
Okay.
Is that okay?
Yeah.
Anybody else need a rewind? And we try to clean up. What can you clean up here? 16 and 40. 16 adds 40 makes 56. Can you do anything about the root of 56? A minute ago, we could do nothing about the root of 13. Can you do anything about the root of 56? Yeah, 4 goes into that. So somewhere in your notebook, you might still have the list of numbers and squares. 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on and so forth. 4 is a square that goes into 56 14 times. So -4 can wait, plus or minus can wait, 10 can wait. If 4 goes into this 14 times, what can we do about this? 2 root of 14. And pause there. Does anybody need me to rewind and explain how we got to there at all? This one's going to go basically as long as they go. This has one more available step. Yeah, what numbers are we going to attack? We can't just attack 2 and 10 unless we also attack the 4. If we have all of the coefficient numbers, if they can all divide by something, we will do that. Who can go into all of those? 2. Some of you have quizzes to fix from chapter 7 with answers on them like 6 plus 8i over 10. That's not best. You can divide those all by 2. Some of you might have things like this. That's not a best answer from last chapter fixing, because we can divide all those numbers by 3. Some of you guys have papers in your possession. You still need to apply that lesson. We've had that before. We're still having it now. If these numbers can all divide by something, we're going to divide them all by that number. Don't touch the root number. The root number is one of a kind. That's best answer on this, is that. Question about that one? That was as much jumping through hoops as you could have to do. Sometimes the root doesn't even simplify. Sometimes it does, sometimes you get that bonus step, but that's about as big as these can get there. So this one, this is
A,
A,
B, Z,
C, no negatives, that makes our life simpler. So what's first?
-3,
-3 from that 3,
plus minus,
plus minus,
square root,
square root,
9,
9,
minus,
minus, 12,
line,
big fraction, 6, and we'll pause there and see if anybody needs help doing what we did. Anybody trouble throwing the numbers in the spaces? Again, back to an idea from the beginning. The absolute key to this is you have to know the formula. So if you mismemorize the formula, you're doomed. You have to really be secure that I memorized this formula correctly, and then you can apply it. Clean up.
9 minus 12,
9 minus 12
negative 2,
is -3. Can you do anything about the root of -3?
no,
We have an I. If we're rooting negatives, we still want to do I play. So -3 weights, plus or minus weights, bottom the 6 weights. This would be an I root 3. And then we'll pause there for a second. A second ago, we launched one more attack. Can we attack here?
Like, divide by 3.
We think divide by 3s,
Put the coefficient.
but no, because what's invisibly here?
1,
A 1. So 6, 3, and 1 are not mutually workable, so we're just stuck. This 3 that you can like seemingly divide, it's in a different classification. We don't even try to touch that. Something there. So for this is A,
B,
B,
C,
C. The most common mistake that people will make could be made on this one because of the nature of this problem. We had this happen once a second ago. What might people mess up on this?
Signs.
Signs. Because who?
2x.
Yeah, the B is
Negative.
-2. So make sure the B, you're counting it as a -2. Then swap the numbers. 2
minus,
minus
square root,
root
4,
4, because a negative squared is still positive.
minus,
Minus 16,
8,
8. Something about how we got those numbers all in those spaces. Everybody rewind. Okay, clean up.
negative 8,
Try again.
12,
Negative 12. So 4 minus 16 is negative 12.
So it's gonna be 2 plus minus
2i,
root 12. Or root 6, right?
Root 3.
3. Oh, yeah.
8,
8. So we got the I because we were rooting a negative. And then the 12, 4 is the square that goes in there 3 times. So 4 roots to 2, and 3 just gets stuck. Anybody need any rewind on that? Done, or do we still have that last step we sometimes get stuck
So
with?
take out a 2.
Take out a 2 from who, and who.
2, 2, 8,
2, 2, 8. So final?
1 plus I root 3 over 4.
Agreed. Something about that. Last one. So A, B, C.
Plus 49. That is
24? 6.
Question about getting the numbers in the right slots, because that's foundational. If you can't get the numbers in the right slots, we need to fix that before we leave the room. Anybody not sure how we're getting these numbers in these slots? Then it's just cleanup. So that makes 25. Can you do anything about the root of 25? Yes. That makes 5. This problem can continue now in a weird way. You have to understand what this symbol means. It means there's a -7 that could
Add 5.
add 5 and then divide by 6. It also means there's a -7 that could subtract 5 and then divide by 6. If -7 adds 5,
-2.
that's -2 on top of 6, which is best as -1/3. Did I disappear off the screen or am I still good?
Your hand's still there.
All right. So I'm gone, but my hand is just invisible, like floating
Yeah.
and writing. So that's fine. I don't need to be on there. They've seen me before. This will be -12 on top of 6, which is -2. What do you think it means if you get a root that you can evenly do? What do you think that meant you could have factored? If you get to a point where there's a root that's doable, that means factoring was possible from the beginning. We could have gone 3x, x, signs, pluses,
1, 2.
1, 2. If we check it, 1x, 6x makes 7x. This would have given us the -1/3. This would have given us the -2. That would have been fine. In the homework, there are some that factor. If you see the problem and you think, hey, wait a minute, I can factor that, that's an easier, quicker road. If you don't notice that and you end up with a root you can do, you could either go back and factor it, or you could just keep working forward, but what you're gonna end up having is a number to add this and then divide, a number to subtract this and then divide. You're gonna have to work those problems out. But if a root becomes on the scene that you can do, because it's on our squares list, that means you could have factored from the beginning. Up to you if you spot those early, late, or just don't care. If you didn't like yesterday's homework, you could go back and take any problem from yesterday's homework and do it with this formula. If you're like, boy, I love this formula, this is great, then use it every problem. I think it's longer. I think yesterday's homework was quicker to chuck through the way we did it, but this works for anything. This is never going away. So this will come up later in our year in this. This will come up in physics, this will come up in trig, it comes up in calculus, it comes up like all over the place. It just keeps coming up in future subjects that you might or might not have with me. But if stuff equals 0 and you can factor, do it. But if you can't, you just have to do this equation. With this lesson underway now, I'm missing the next 2 days for the Ohio Journey. The 8.3 lesson is already up. The 8.3 lesson is talking about a couple features of this formula. It mostly centers on this part. When this could go one of 3 ways. Half the problems today, this number turned out to be rooting a positive, and half the time we were rooting a negative. It's also possible you might be occasionally rooting a 0. When we rooted a positive, we got 2 real answers. When we rooted negatives, what did we get?
What?
When we rooted positives, we got real answers.
Eyes.
When we rooted negatives, we got eyes, which are called imaginary or complex answers.
I was getting I always had it. It was there. But I second thought myself.
Some of tomorrow's lesson, they won't ask you to do the whole formula, and you can watch the video, but it's a teaser of things to come that I'd rather do in person with you than just force videos on you. They'll give you problems like this and just ask you, what kind of answers will it have? So you just have to run the 25 minus 12 part, and since it turns up positive, you know that there's 2 real answers. Or on a question like this, if you just run the 9 minus 12 part, you know that's negative, so that has 2 complex answers. You know, that's the video is going to talk about some stuff like that, little tidbits of things that go on with this. But 8.3 is based on this. 8.4 is more like 8.1, maybe with a twist, but now that you've had this, you have enough knowledge to do the videos. You could do 8.4 before 8.3 or 8.3 before 8.4, but once you've had 8.1, 8.2, you can absorb 8.3 or 8.4 videos. So people on the journey with me, watch the videos sometime in your free time. People that are here in person, the sub is just going to drop the screen and show you videos the next 2 days. Homework today we're working is 355. 355, we're going to skip the 3's. and we're working as far as 2. Some of these problems do have to have a little bit of distributing or something first before you can start them, but for the most part, you just kind of jump in and they equal 0 and you just do what we were doing. Anybody, any kind of question about what's going on today, tomorrow, future? Okay, that's it.